Okay, so let's continue our lecture 3. So the next part is supervise. So let's consider this case in this image. So if I have tagged my emails to be a ordinary email or a spam email. So if I have tagged enough emails, the next thing will be I want to send all the tagged emails to a machine learning model. So after the machine learning model learned from those training datasets with the with the ordinary emails versus the spam emails already labeled. Eventually, I want to have a new email there. And then this machine learning model should be able to tell me, is that a spam email or this is just an ordinary email I should read. So in this case, I'm tagging the values, the ordinary emails versus the spam emails first. And then I'm sending the data with the tags to the machine learning model. So the machine learning model will find the potential features from the training dataset, and eventually it will be able to predict the labels, and the labels will be either a ordinary email or a spam. So this is the goal of the supervised learning. When we send the data to the model, those data are already tagged or labeled. And the machine learning model will just receive this input and then learn the hidden patterns by itself using whatever algorithm we specified. So this is the idea of the supervised machine learning. So just now we had one example, and then we are trying to predict the labels. And for the labels, they are not continuous data, right? And in lecture number 2, we did a regression. So for that regression, we are not predicting labels, we are predicting values. And those two are kind of different. Well, one is we are dealing with labels, and two, we are dealing with values. However, for both of them, we know the labels, or it's the better word for that is we know the ground truth. So as long as we know the ground truth, that is a supervised machine learning. And the next part is, well, if we do not have the labels, and then we are dealing with the unsupervised. But here, well, if you have seen this book, the data mining concepts and technologies by Han, well, that's a textbook I talk about in day one, and that is a textbook written by researchers. And I said this is not a super fun machine learning book to read, but their definition is if we are predicting the class labels, well, this task is classification. Or if we are predicting the values, for example, with linear regression, and we call that a prediction. Well, however, no matter we are doing classification or prediction, they are supervised machine learning. So here is a short exercise, and there are 4 tasks, and read them and see which one is the supervised classification problem. So take a look. Well, you can pause the video for now. Okay, so, well, let me give you the answer. The answer is the number 1. The number 1 is a supervised classification. So let's see why. So the number 1 is using labeled financial data to predict whether the value of the stock will go up or down next week. So there are only 2 possibilities, go up or down, right? So those are the data, or those are the labels. And then we are using labeled financial data. So the data set we are receiving is also labeled. So number 1, we have labeled data, so it's supervised. And number 2, we are trying to predict go up or down. That are 2 possible labels. So that is supervised classification. So let's see 2. 2 is using labeled house price data to predict the price of a new home based on various features. So that is labeled data again, but however, we are predicting values. So predicting values, that is prediction. So number 2 should be a supervised prediction problem. And the number 3, using unlabeled data to cluster students of an online education company into different categories. So that is unlabeled. So that is an unsupervised problem. And it is also a clustering problem because we are trying to put the students into different clusters. And the number 4, using labeled financial data to predict the value of a stock. Okay, so that is label data. However, we are predicting the value of a stock. So that is a supervised prediction problem. Okay, the next part, unsupervised. So for unsupervised, we have already said, well, this is a type of machine learning without the ground truth. So you may say, without ground truth, what can we do? Right? So actually we can still do something. So here on this one, we have already got one example. So even though we don't have the labels of the students, well, students learning may have some patterns. So if I'm running a online education system or a online quizzing system, and then I'm giving students work to do every week, and eventually I will have some of the students, they are clustered. They have a cluster to be early birds. So early birds, for example, when a test is posted, and then those students will start to work on those questions early, and there will be another cluster, and I can call them last minute people. So they will start working on the things right before the due date. Okay, so those are at least two different parts, two different clusters. So that is type 1, which is the clustering. And there's another type called association rule. So that is, even though we do not have the labels, we can see what are the features usually show up together. And one very, very old example is, well, I believe I have talked about that. That is the diaper and the beer. So if you collected the data of the shopping records of a grocery store, for example, and you may find something surprising. And one of the things is, well, for the customers who buy diapers, they also buy beers. So they are very likely to buy beers. So, and they did some study, and the reason was there are some fathers, they're staying at home taking care of the baby, and they get really bored, or they just need some alcohol to cheer themselves up, probably, and so they decided they want to treat themselves with some beer, and this might be the theory. So this is called association rule. That is, what are the features, or what are multiple features will show up together, for example, like diaper and the beers, and what can you do with that? So if you're a manager of a grocery store, you can put the diapers on one side of the store and then the beers on the other side of the store. So when a dad wants to buy both of the things, and then they have to go all the way from one side to the other side, and then they may see something else, and they may buy some extra things, and that is exactly you hope your customers will do. So the next part, what are some of the other categories? Well, some textbooks say there is another type of machine learning called reinforcement learning. Well, I personally would not agree with that. So just now, the two types of machine learning we talk about are supervised and unsupervised, right? So the difference between those two is whether we have available label data or not. So between the supervised and unsupervised, there is another type called semi-supervised. That is, if we have some of the labeled data, but the majority of the data are unlabeled, and then what can we do with this kind of data? So let me give you an example, and I'm going to do that with a tablet. So this will be my whiteboard in this semester. So let me swap to the drawing board. So let me give you an example. So in our sample, we have a bunch of black samples here. So that is one class. And then we also have a bunch of red samples. Okay, so we have some black samples, we have some red samples, and those are the label data, for example. And then we also have a bunch of unlabeled data in different places. So for example, here we have an unlabeled data, and here we have another unlabeled data. So using the current available label data. And we may say for this one, for example, on the right side, this one is likely to be a red sample because it is so close to the other red samples. And for this one, on the left side, this is likely to be a sample of black class. So for those two samples, well, we will say we can comfortably label them because they are quite similar to the black samples or to the red samples. But let's see, we have one here. So if we have one here, it is kind of in between the black class and the red class. So what is that? That one can be really hard. So if you are doing a machine learning called active learning, so if you are doing active learning, what you should do with this sample is actually you should ask your domain expert. So if your domain expert says this is a black sample, and then the decision boundary of the black class and the red class might be something like this. Okay, so if the new sample here is a black sample, and then the boundary of those two classes might be like that. However, if this sample turned out to be a red sample, so if this one is a red sample, and then the decision boundary will be changed totally, which will be like this. Okay, so based on how this sample is labeled, the decision boundary between those two classes can change drastically. So what are you going to do with this sample? If you're doing active learning, you are assuming the domain expert is available, and then you should ask your domain expert. So that is the active learning is actually one of the example of the semi-supervised learning. So we start from a limited set, one limited set of the label data, and then we want to expand that, so eventually we want to figure out the decision boundaries between two clusters. So that is semi-supervised learning. So that's it for number 3 lecture. So I will see you later.